So the first method is called present worth method. And this is very easy to understand. So the present worth method is all cash flows at various times are represented by their equivalent values at a point in time called the present. Here, the I% is MARR. So like what I said, you just want to draw the cash flow diagram and then convert all the cash flows back to the present and using the I% equals to MARR. And to see if the present worth, or we can say actually it's P0, if it's bigger or equal to 0. And at the MARR, which means you use MARR as the I% for the conversion. If it is bigger or equal to 0, then the project is acceptable, okay? If not, you're going to reject that proposal. So usually you're going to have single cash flow at the end of the nth period. That's the first case, okay? So it is easy. You just need to make this future cash flow, convert that back to the present time. Okay, so you want to see what is P0 and compare that with 0. And another case is you're going to have cash flows every year. So you're going to have annuities. Okay. Could be earning, could be spending. So you want to convert all of this back to present time, and still you want to calculate what is the P0 and compare that with 0. Okay, so this is very easy to understand. Now let's take a look at this example. Alright, so the example said, a piece of new equipment has been proposed by engineers to increase the productivity of a certain manual welding operation. The investment cost, so it's a capital cost, is $25,000. It means at the beginning, at present time, you need to pay $25,000 to buy the equipment. And the equipment will have a market value of $5,000 at the end of a study period of 5 years. So after 5 years, you can sell this equipment to the market and you get $5,000 back. Increase the productivity attributable to the equipment will amount to $8,000 per year after extra operating costs have been subtracted from the revenue generated by the additional production. So what this means is, while you have some savings from the machine, you also need to have some operating costs and expenditures to use this machine. But the net saving, okay, the net saving is $8,000. Okay, so that is the net receiving of money in your company. And it happens every year, so it's kind of annuity. So first thing is and also the firm's MARR is given as 20%. Okay, so now how do you decide if this is a sound project or not? The first thing is we need to draw the cash flow diagram. Okay, so we draw it from the perspective of this company. From the company's perspective. So the cash flow diagram is you have 0 and it says the lifetime for this project is 5 years. So you have 1, 2, 3, 4, and 5. That's your timeline. So at the beginning, you need to pay 25,000. That's the expenditure, so it's going downward. And in the end of the 5th year, you can sell it as at 5,000. That's your receiving. And every year you can save a net receiving as 8,000. So that's 8,000 going upward. Okay, so the A is 8,000, and the I%, which is the MARR, is 20% per year. Okay, so that's the cash flow diagram. And now you want to convert everything back to the present to have the PW, the present worth. Actually, what you want to have is the P0. What is that? But you know it is PW, okay? It's better to write it this way. So PW, the present worth method, you want to calculate the PW, but actually it is the P0, right? But what is P0? Now the problem is multiple cash flows problem. Remember that? You need to determine how many parts of P0 you have. Okay? So how many parts? You have the first part, okay? And the second part of annuity, from the annuity, and third, you have the P0, part of P0 from the future value of 5,000. So that's the 3 part. Okay, so P01, that's the first part. That is from the 25,000. And you know it is a present time value, so it's P. And the second part is from the annuity, which is 8,000 every year. And you know it is a type of annuity, right? And the third part is from the future value of 5,000. So that is a future cash flow. What's going on with my pen? Okay. All right. But you know you want to convert all the cash flows back to present. So you want to convert this to present. You want to convert this to present. You want to convert the future cash flow to present. That's your goal. So now let's do the conversion. So P01, it is already at present. So there's no interest rate going on. You don't have to convert anything. So 25,000 is 25,000. But it is the expenditure, so it's negative. So negative 25,000. That's the first part. And the P02, it's from the annuities, so it's to find P given A, okay? And it's receiving, so it's positive. The equation to find P given A is A times a factor, which is P slash A. The I% is MARR, right? You can just write it directly like that. And then N. So it's positive. A is 8,000. the factor is P/A, MARR is 20%, N is 5. Okay, so now you need to check the table of I equals to 20%. You want to find P/A, and the number of years is 5. So here is your factor. So it is positive 8,000 times 2.9906, which is positive 23,924.8. Okay, and next let's calculate P03, the third part. Still, it's a receiving of 5,000, so it's positive, and it's to find out present value given future value. So the equation is the F times a factor P/F MARR N. So positive 5,000 times the factor is P/F 20% and 5. It's positive, so let's give it a borderline here. You gotta find this factor in the table. So it's P/F and 5 years, so this is your factor, and that is 0.4019. So the final result is 2009.5. Okay, so now what is the P0? The P0 is the sum of P01 plus P02 plus P03. Okay? P01 is a negative number. It's 25,000. P02 is 23,924.8. And P03 is 2,000. Why it's so thick? Let me write it down here. So 2,009.5. Okay, and the final result is positive 934.3. So your PW is P0, which is a positive number, 934.3. It is bigger than 0, obviously, which means this project is a sound one. Okay, so that is your conclusion.